Hey, my name's Nick McRae. I'm the composites engineer at Reserve Wheels. In 2019, we began a research project to push the frontiers of road wheel aerodynamics. Bike engineers have used wind tunnel data to improve aerodynamics for decades. Work in the 1980s and 90s drove significant leaps in drag reduction. But in the last decade or so, the big gains have pretty much stalled out. We made it our mission to find out why. Wind tunnel testing for cycling has always been conducted under smooth wind conditions, known as laminar flow. Anyone who's ever ridden a bike on an open road knows that laminar wind flow is simply not what you experience in reality. On a bike, wind doesn't flow across you in one continuous speed and direction. It blows inconsistently from all angles. In other words, it is turbulent. We concluded that if we could design and test wheels in turbulent conditions, we just might be able to make a new leap forward in aerodynamics. Step one was gathering data. So we built a sophisticated system using air probes from jet airplanes to measure wind intensity and orientation. We traveled around the US for 2 years with it, looking like storm chasers. It was all worth it though, as the data allows us to replicate real-world conditions back in the wind tunnel. It is these tests that now determine what the most effective aerodynamic wheel profiles actually are in reality. Reducing drag isn't everything though. You only ride fast if you feel confident riding fast. So we also focus heavily on ensuring our profiles offer as much stability as they are efficient. That's why we offer mixed profile road wheel pairings throughout our range, denoted by the two numbers which equate to the rim height in millimeters. In general, taller rim profiles create less drag and thus offer distinct aerodynamic advantages. However, the turbulence measured by our system reiterated the need for lower profiles on front wheels. By making the front wheel profiles slightly shorter, wider, and rounder, we decrease the effects of crosswinds at the handlebars, increasing front-end stability across all wind conditions. By comparison, the rear wheel has very different design parameters than the front. Here, the wheel is partially shielded by the frame and rider, meaning air is already deflected before it meets the wheel, way more turbulent than at the front. This reduces the negative impact of crosswinds and completely changes the aerodynamic conditions the wheel needs to perform in. As a result, the rim rear profile can be made taller and narrower than the front to minimize drag. That's why we make a full disc wheel for extreme use cases like Team Jumbo-Visma's time trial bikes. But a taller rim means more material. More material means more weight. So here again, the focus is on finding the right height for the use case. Our rear wheels also have an asymmetrical profile to offset the rim away from the cassette. This creates a stronger, stiffer, and more durable wheel. And on bikes like the Cervelo S5, it enables the wheel to tuck into perfect alignment with the asymmetrical frame, thus reducing drag yet further. So there you have it. Turbulent Aero marks a milestone in the evolution of road wheel aerodynamics. Real-world data and Turbulent Aero technology combine to create the fastest, most stable wheel set for real riders in real-world conditions. So if you see our scooter out in the wild, give us a wave.